So have you ever wondered, how do stars die? Pretty morbid, I know. But massive stars literally go out with a bang, and smaller stars kind of just fizzle out. So then, how do stars die? Well, they end as supernovas. There are two types of supernovas. For a massive star, it will run out of fuel and have its core collapse into itself and then explode into a supernova. Smaller stars' only hope at literally going out with a bang is to suck the life out of another star. No, seriously. A white dwarf in a binary star system can begin accumulating fuel from its companion star and eventually have its core collapse and eject mass. We've heard this story before. But still, how? The question still hasn't been answered. How do stars die? Okay, I promise I'll stop doing that. But anyways, the death of a star is essentially caused by a process called supernova nucleosynthesis. It may look a little bit scary, so let's break it down. The Merriam-Webster Dictionary defines nucleosynthesis to be the cosmic formation of atoms more complex than a hydrogen atom. Or in actual English, it's basically the creation of a new nucleus from already existing protons, neutrons, and nuclei. But again, how? How does any of this cause a supernova? A star is mostly made up of lighter elements, such as helium and hydrogen, and in the core there's a process called fusion going on. When this happens, the lighter elements are turned into heavier ones during different hydrostatic burning stages. There's helium burning, oxygen burning, and silicon burning phases. Let's take a look at helium burning. It happens at about 10 million Kelvin. During helium burning, the helium atoms either collide with each other or with other protons, neutrons, and other nuclei floating around to form carbon, a much heavier element. So this is how that happens. Let's look at two helium atoms colliding. They're both just floating around in the star's core, and when they collide, they produce beryllium and release energy. The beryllium may collide with another helium atom or other byproducts to release energy and produce carbon. Eventually, the carbon will collide with other byproducts and continue creating heavier elements until the star builds up most of its elements to iron or higher. There are 4 different nucleosynthesis processes, but the one that occurs mostly during supernovas is the R process, which is basically neutron capture. This happens when heavy nuclei are bombarded with a large flux of neutrons to form highly unstable neutron-rich nuclei, and it'll decay into a more stable nucleus. So the excess neutrons from the previous reactions is what helps create the heavy stable elements, and neutrons can enter the nucleus more easily because protons in the nucleus repel them. And these burning stages continue until there is no more fuel left. A little aside, so you know how the star's core goes through different burning stages? Well, since not each element reacts or undergoes fusion, these giants actually have an onion structure, which is pretty wild. Okay, so back to your regular scheduled programming. Now the star is basically full of heavy elements, and the core can't take it. The core gets so heavy that it cannot withstand its own gravitational force and collapses, resulting in a supernova. And that's how stars die. Through supernova nucleosynthesis and the fusion of elements, the core gets so heavy it collapses and then explodes into a supernova.